Hey everybody, we are on for today's lesson, which is going to look at continuing the skills that we talked about last class and being able to find the nth pattern. You're going to need to know that in order to move on. I thought we could start off today's lesson with just a kind of a reminder of what we talked about in the last class. Because I know that some of you said that you were still a little bit nervous about what we were doing. So just really quickly, we can do one together. Let's say that I gave you the pattern of 3, 8, 13, and then 18. And I asked you to find a pattern rule for the nth term. So once again, you would create a table. So your first, your second, your third, and your fourth number, right, represent these ones here. That's the first, the second, the third, and the fourth. And then you'd put in the other part of the table, that's the term number. The term value, you'd put the value associated with it, 3, 8, 13, and 18. And then you would simply try to find out how much are they increasing or decreasing by. This increases by 5. This increases by 5, and this increases by 5. So because you know that it's 5, we know that it's 5n, and the 5n represents the term number. And then we would find out how to, we could do the zero term if you want to work backwards and you're okay with integers into the negative, but we can also just plug it in. So 5 times 1 should equal 3. It's not going to. So we have to ask ourselves, how do we get from here to here? We're going to subtract 2. So it's going to be 5n minus 2 would be our term rule. Okay, so that's just kind of a quick reminder of yesterday's class. Let's talk today's class, and let's talk about what we're going to be looking at today. So today we're actually going to be looking at exploring patterns on a grid. Okay, and the same idea is going to be true, but we're going to be graphing it. Now, the crappy part for me is that I don't have any grid paper, unfortunately, and I don't have a printer at home, which will allow me to print grid paper. So Mr. Berger's going to do some freehand gridding. So what's some information you need to come into this this lesson with? So we're going to be dealing with something called ordered pairs. You might have seen them before when we do like translations, transformations. Luckily, that's not such a big thing in grade 9. But an ordered pair is 2 plot points, right? So let's say 3 and 12. These are plot points on axes, right? This one stands for the x-axis, and this one stands for the y-axis. When we're doing algebraic expressions and we're using these coordinates, the first number is going to stand for the term number, and the second number is going to stand for the term value. Okay. So that should kind of give you a hint that the term number will always be on the x-axis and the term value will always be on the y-axis. So if you're given an ordered pair, you can still find the pattern. So if I was given this ordered pair right here, if I was given, let's say, 1, 11, 2, 17, and 3, 23. Although they are coordinates on the graph, they're simply the same as writing it out as a table, right? If I took this idea and wrote it as a table, I would put the first number in the term number, I put the second number in the term value, and so I might have been asked to graph this or plot it, but I might have also been asked to write the pattern rule. So if I was asked to write the pattern rule, I would see that each of these numbers is going up by 6. So it would be 6n. And because it's a larger number, I'm going to work backwards, and I'm going to find that this is 5. So it's going to be 6n plus 5. Okay? So ordered pairs are what we're going to be dealing with during this lesson. And we're going to talk about how to plot a little bit in a little bit. Okay, so let's do our first question together. So let's say that we have, and Mr. Berger's going to do his best to draw let's say that we have a plant, a pot, oh, so it doesn't work. Let's say we have a potted plant holder. So like, I'm just gonna draw a quick one. Say that's for our plant. Actually, that's pretty good. And let's say that the height of this plant pot is 9 centimeters. And let's say we're gonna stack plants inside this. So you'd actually only see the lid. And this lid is 3 centimeters. And we could continue to stack pots and stack pots. And let's say I wanted to find out and I wanted to graph this algebraic expression. So the first way we're going to learn how to do that is by if we're given the algebraic pattern rule. So let's say that the pattern rule for this was height equals, can you see that? There we go. Height equals 3n plus 9. Okay? So the first question is, why the plus 9? Why is that the constant? Well, it's the constant because that pot is always going to be there. Okay, so no matter what, when we're stacking pots, this is always going to be the base, right? So we are almost considering when you stack a pot, you have to have something. You can't just say like, oh, this pot by itself, that's stacking. No, it's not stacking. It's a pot. This first pot, that's when you start stacking. So the height of the entire pot is 3n plus 9. The 9 is the height of the first pot, and the 3 represents the height of the lid of that pot. So the height of that little piece. So how would I be able to find out, let's say, the first 3 pots? So for our first pot, so for one pot, I'm going to look at it in this way, right? I'm going to insert, one pot. I'm going to insert into the n, I'm going to insert 1, right? Because it represents this first pot right here. So I'm going to do 3 times 1 equals 9. 3 times 1 is 3 plus 9. And if the first pot all the way down to the bottom, it's 12 centimeters. If I want to do the second pot, I'm just going to do like this. I would do the exact same thing. I would say now I'm going to do 2 of these lids plus 9. So I'm going to do 6 plus 9. I'm going to get 15 centimeters. So now I'm saying from here all the way down, whoops, this one's from here, is 15 centimeters. And then if I want to find the third pot, I would say it's 3 times 3 plus 9. So 9 plus 9, which is 18 centimeters. So that third pot all the way down to the bottom, it's 18 centimeters. So great, we've got this information, which is really helpful. Now we know what the heights are. Now we have to create our ordered pairs. So in order to create our ordered pairs, we need to look at okay, what is the pot and what is the height? So in our ordered pairs, the first number is going to be the number of pots. The second number is going to be the height. So when there's one pot, what was the height? 12 centimeters. So it's going to be 1 and 12. When there's 2 pots, the height was 15. And when there was 3 pots, the height was 18. These are now our ordered pairs that we're going to add to our graph. So once we have our ordered pairs, we can just go ahead and we can fill out our graph. So I'm going to do my best here to draw a graph. And we can start at 0, but our first ordered pair is going to be from 1. So 1, 2, 3, we could keep going up to 4 if we want. We can look at this and say, okay, I don't have to start at 0 on the y-axis. So, sorry, I'm just going to label this quickly. This is the number of pots, flower pots, and this is going to be the height. So I don't have to start at 0. So what I'm going to do is I'm going to use my little pulse thingy. And I'm going to start at, I think my first number is going to be 10. And I'm going to go up by 2. 10, 12, 14, 16, 18, 20, 22 seems like a good amount. Yeah, I'm going to do that. Okay, so what I'm going to do now is I am going to plot these out on my graph. So I'm going to say to myself, okay, 1 is going to be at 12. So I'm going to go here. I'm going to plot that out. 2 is at 15, so it's somewhere in between here. 3 is at 18, so it's going to be right here. And I could very easily just know where 4 is going to go because I just have to add 3 onto this one. So 4 is going to be at 21, so it's going to be in between. And now if I wanted to graph this trend, I could just draw a straight line all the way through, starting at 1 and going up. You can see that it's a growing pattern from where the plotted points are. Sometimes you might be asked to actually write down the plotted points. For this case, I'm just showing you what you would do, but you don't have to do it in this lesson today because it's not one of the parts of the curriculum that we have to hit. So there you go. So now that first one was when we were given an algebraic expression. We worked through the algebraic expression and we ended up plotting on a graph. Let's go to another one. What if we're not given the algebraic expression? What if we're given something else? What if, for instance, we are given a chart? What if we're given a chart and we're asked to find the ordered pairs from a chart? So let's say I'm going to start off in this corner over here. Sorry, guys. Boop, boop, boop. Say I was given a chart. And let's say that we have a school play going on. Okay. And in this school play, we have to buy tickets. So the people who are throwing the school play have to buy boxes of tickets. So they can buy as many boxes of tickets as they want, but no matter what, there's a $15 ticket art fee, right, to design the ticket. Okay, so whether they buy 1 box or 25 boxes, there's always going to be that $15 art fee that's going to be on top of it. So we're going to create our chart. So our chart's going to be, we're going to represent the term number with the amount of boxes that they can buy. And we're going to represent the term value by the cost of it all. So if they buy 0 boxes, and they just get the tickets, if let's say they want to see what the ticket looks like, they still got to pay that $15 art fee. So if they buy 0 boxes and they still do the art fee, then we know that the term value is going to still be 15. If they buy 1 box, what will it be? It'll be 30. If they buy 2 boxes, it'll be 45. If they buy 3 boxes, it'll be 60. Okay. So the amount of boxes that they buy, the art fee will continue to go up. So when they buy 0, it's going to be $15. So how do we create these ordered pairs? Well, you probably can see it right away. You're going to take the term number and the term value, and you're just going to go read across and put a comma in there. So you're going to have 0, 15, 130, 245, 3, and 60. What are you noticing in this scenario is the constant. That's right, it's the $15 ticket art fee, right? The number of boxes can change. So I've got my ordered pairs. What if I was asking you the next step was to create me an algebraic expression for the pattern rule? So we've got my ordered pairs. I'm going to look at this. I'm going to say to myself, all right, to go from 15 to 30 is 15, and then 15 and 15. So it's going to be 15n plus what? Plus automatically what? Well, there's automatically a $15 fee, right? So if I did 15 times 0 should equal 15. It would be 0 equals 15, which means that I still need that art fee. Okay, so we have to make sure that we have the ability to make our algebraic expression in the same way, because it's not just good enough to plot the points, it's also you need to know, because let's say that I was asking you for the 75th, they buy 75 boxes, and I wanted you to show me that on a graph. You would need to be able to plug that in. So we've got our ordered pairs. Let's put them on a chart now. Once again, I'm going to say that I'm not going to start at 0. Okay. But here I'm going to start at 0. So I'm going to have 0, 1, 2, 3, and let's keep going. Let's go 4, and let's go 5. And then here I'm going to start at 15, and I'm going to go up by 15. It's 30, 45, 60, 75, 90, 105. And now I'm going to plot. Now if I'm plotting here at 0, then I'm going to actually put it on that line. So it's going to go 0, 15. And then 1 is going to be at 30, 2 is going to be at 45, 3 is going to be at 60, 4 is going to be at 75, and then 5 is going to be at 90. And so once again, I can see that if I draw a line through and I'm asked to describe this trend, well, it's an upward, it's a growing pattern, and it grows for every box. You're paying an extra $15. Okay, so that can tell me how much each box is costing, right? So each box costs $15, and I can tell that in my algebraic expression. Let's make this an application question. So you're given the problem, you've worked through, you're given this table to work through. You're able to create the algebraic expression, and you've plotted the graph, and I now want to make it an application question, and I want to know from you is the cost for the 35th box. Okay, so what would you do in that scenario? And if you've said, okay, all I'm going to do is plug this in to my equation. So if I do 15, and I'm going to rewrite the expression. 15n plus 15. So I'm going to do 15 times 35. Oh, I did it so low on this page. Sorry, guys. Let's move it over here. 15n plus 15. So I do 15 and 35 because the n is representing the amount of boxes plus 15. 15 times 35 is 525 plus 15. 525 plus 15 is 540. Therefore, 35 boxes would cost $540. Okay, so we've gone from getting it in a chart, and given this information, you know that when you're given a chart, all you're doing is you're going to write your ordered pairs from left to right. You've figured out by looking at your term value what the algebraic expression is. You've been able to graph it properly, and then you've been able to apply it to a new problem. Let's do one on your own now. Let's try one for you guys on your own. Here is the one. Let's say that, let's pick somebody, Carrie. Carrie, it's quarantine time. Carrie's measuring the height of recycling bins. Don't ask me why, but he is. So he's come up with this chart. So this is the number of bins. And this is the height in centimeters. So he's found out up to 4 bins stacked, okay? The first one was 5, the second one was 9, the third one was 13, and the fourth one was 17. First thing I want you to do is I want you to tell me the ordered pairs. Then I want you to graph it. And then I want you to write me the pattern rule. Okay? And so hit pause do your best. Let's see what you guys come up with. Okay, so you're back. So let's do this in different points. So let's do the ordered pairs up in this corner over here. So all I wanted to see what that you were able to do, you notice that what I did a little differently to try to maybe trick you out was to write the table a little bit different. The height of bins is our term number, and the number of bins is our term number, and the height of bins is our height as our term value. So our ordered pairs would then be 1, 5, 2, 9, 3, 13, and 4, 17. So if you got those ordered pairs looking like that, you're perfect. Some people often make the mistake in writing like this, 5, 1 instead of 1, 5. This would mean that on your x-axis it's going to be 5, and on your y-axis it's going to be 1, which would not show the right pattern. Then I asked you to graph it, so we'll just do a quick graph, and we'll start at, what should we go up by? Probably start at 4 and go maybe up by 8. It doesn't matter what you went up by, as long as you went up by the same amounts. And then at the bottom, you're gonna have 0, 1, 2, 3. I'm sorry, guys. I wish I had chart paper or graph paper. So 1, 5 will be just above this area. Maybe I should have gone up by 2s now that I'm looking at it. 2, 9 is just above the 8. 3, 13s is just above the 12. And 4, 17s is just above the 16. So I can see that it's a growing pattern. I could, if I really, really, really wanted to show off to Mr. Berger, I could label it, but I didn't ask you to. And then the last part was the rule. So what is the rule? Well, I can see that this is going up by 4 each time. So that means it is a linear equation, which means 4n is the start of it. I could work backwards if I wanted to and subtract 4. If I subtracted 4 from 5, I'd have 1. So it would be 4n plus 1. Mr. Berger is a really big keener for checking your work. So I'm just going to check it really quickly. I'm going to do the second one. 4 times 2 plus 1 should equal 9. 4 times 2 is 8 plus 1 equals 9. Great job. Maybe this guy will be dabbing. How do you dab? You dab like that with your other arm like this. There we go. Okay, excellent job. You got a good dab from this guy over here. You did it. Let's do another one though, just to kind of keep testing us. Here I gave it from a chart. This time I'm going to give it to you I want you to do it from getting the actual. So the height equals 12 plus 3n. I want you to complete a table for 5 boxes. And then I want you to graph it, because I'm not going to make you do the algebraic expression because it's already there. So I want you to find me a table for the first 5 boxes stacked on top of each other, maybe stacking cubes or stacking boxes. Okay, pause and get going. Go. Okay, you are back, which means that we are ready to try this out. So if I was creating a table, term number, term value, or this could be height, and this could be boxes, okay, whichever one you put. You should get into the habit of using these instead of TN and TV if they're giving you what is being measured. So box, 1 box, 2 box, 3 box, 4 boxes, and 5 boxes stacked. So what would I have to do here is I would have to input my information into the equation. So 12 plus 3 times 1, 12 plus 3. So 1 box stacked is 15 centimeters. I can do number 2, but I already know that it's going to go up by 3. So I already know the answer is going to be 18 here, because I look back and I see what the variable is going up by. It's going up by 3. So I can already fill this out, but just to be safe, I'm gonna just quickly do the math. 12 plus 3 times 2 is 12 plus 6, 18, right. So once you figure out the first one, if you look back and see what the variable is moving up by, you're pretty much knowing what your pattern is gonna grow by. And then I asked you to graph it, and again, yours, in order to graph it and showing your work, what did you think you'd have to do? I didn't put it on this list because I need you to understand that when you're graphing, you need to show the ordered pair somewhere. So you should have written out, and now you know if you didn't, you should be writing out your ordered pairs somewhere in your answer so your teacher can see that you've communicated the fact that you know that these are plot points on a graph. Okay? So I'm just going to quickly, what is our lowest number? 15. Let's go up by, highest number is 27. Let's go up by boxes, height. Let's go up by, let's go up by 2. 16, 18, 20, 22, 24, 26, 28. Perfect. We've got 1 box, 2 box, 3 box, 4 box, 5 box. Let's plot them out. So 1 is at 15, 2 at 18, 3 at 21, 4 at 24, and 5 at 27. And then I could simply draw a line through it. Sorry guys. I could simply draw a line through it, and if I've done it correctly, it would show, if I continue to go up and across, it would show where 6, 7, 8, 9, 10 at the bottom would go. Okay, so that's kind of getting us started with this knowledge section. We're going to go to the application section and do 2 quick questions, and then we'll end with a quick thinking section as well. Okay, see you guys in a bit.